Hi, Mr. Seward here. This video is about our Engineering CAD reverse engineering project, the objectives and deliverables list. You're going to see a list of the different types of things that are going to be on or involved in making your project here. And something that's different is I have what are called TBA, which is a title block A. That's a regular 8.5 by 11 piece of paper, and TBB, that's a title block B. That's 11 by 17 piece of paper. And different drawings will get put on different sizes of the paper. You'll see that in a couple of seconds. Anyways, here's the design brief. You are an engineer that works someplace that is going to reverse engineer something. Many reasons why reverse engineering gets done, ranging from they're looking to see if they can improve a product that they have made or that somebody else may have made. They also might be looking for patent infringements from somebody else, or they simply may have lost any documentation that they had of a part. Computer virus, somebody hijacks their data. You never know exactly what's going to cause data to get lost these days, unfortunately. So they might have to take out a pair of calipers or other measuring tools and start working on something. So you're going to be an engineer for a manufacturing company that's lost all of its electronic documentation for some reason, and it's going to be your job to reverse engineer a product that has at least 7 different parts. You're going to use calipers or other measuring tools as needed to make drawings of the items of the parts as you take it apart and you create the part files. After you have documented the item by measuring it and drawing it, then you're going to make a Google website that we're going to use as a digital portfolio for this class. And included on the website will be individual pages for every part with a written description of the part below it. So, objectives. You're going to use Onshape to create the parts and to assign materials and colors to them. You're going to need the materials in particular for when we do what's called a stress analysis. More on that in a little bit. Colors, you're going to need to do colors on your parts. The reason for that is we're going to make what's called an exploded view. You'll see one of those in a bit also. An exploded view is also going to be printed in our LMC in color, and it's kind of a nice way to make a nice looking drawing. You're going to use Onshape to create 2 different assemblies. The regular assembly that has the parts list / bubbles, and then a second one that's just called an exploded assembly. I just mentioned that a couple minutes ago. You're going to use Onshape to create a full set of working drawings. So on TBAs, you're going to create a cover page with an assembly view of the project and information like your name, the school's name, the school's year, and the project title. On TBA also are going to be part drawings that are going to be required to put like front, top, and right views on, just like if you were going to manufacture the parts. They also need to be fully dimensioned, so they need to have an overall length, an overall width, and an overall height. Maybe fully dimensioned is a little loosely interpreted there. I just want those 3 dimensions on there. You don't need anything more than that. As required for clarity, specialty views like details or section views or broken view or auxiliary views can be used. That's a you decision, not a Mr. Seward decision. On to a TBB, you're going to put the assembly with parts list and bubbles. That's going to be unshaded, just a regular part drawing, I guess, or assembly drawing. And then on TBB also, you're going to make the assembled exploded assembly drawing. That says with a parts list on here. I'm going to remove the word with a parts list. So I'll get rid of that right now. didn't catch that when I was proofreading, but that is going to be shaded. So you'll see that in a future video about how I go about doing that. So you're going to use Onshape to create also a stress analysis report for the assembly, giving specific stress analysis criteria. And there'll be another video about how to do stress analysis using Onshape and an add-on or two that we might need. In the end, you're going to create a website that we're going to use as a digital portfolio for this class and create a button or tab for the project that is going to have evidence and or documentation for the deliverables of this project. So I'm talking about the drawing files for all the parts that are involved in this, file also for the regular assembly, a file for the exploded assembly, a file for the cover page. All the pages are going to be on this website. So here is the deliverables, your Onshape document. So you need to create a new document when you begin Onshape. You're going to share it with me, and that's my email address right there. You're going to then go start making part studios for all 7 or more parts of the project. And for sheet names, you're going to have the TBA is going to be cover page. So title block A for the cover page, title block B for the assembly that has the parts list in bubbles. Make sure you have included on that all the views necessary to document that assembly. All the parts have to be bubbled, and you have to have a parts list that includes all 7 or more parts that you have in your assembly. Also on a TBB, you're going to have your exploded assembly. That's going to be colored and shaded, and you're going to make sure that that includes the fully exploded view that's colored and shaded again, that is going to be put onto a TBB in the LMC and printed in the LMC. The TBA is going to be for any working drawings with those 3 dimensions, the overall length, width, and height. And you're also going to make sure that you do this stress analysis report for the assembly. So that's the project. This is going to be available to you, this page, on the Google Classroom. Thank you very much for watching.